So, artificial intelligence is pretty much everywhere you look. But have you ever stopped to ask how it actually, well, thinks? It's not some kind of magic, I promise. It's really a set of rules. Today, we're going to break down the 7 core principles that are basically the blueprint for all modern AI, from the simplest little algorithm to the most powerful neural network out there. This quote just hits it right on the head. It perfectly captures the massive shift we've all been living through. What used to be the stuff of sci-fi movies is now the invisible engine running behind so much of our digital lives. So understanding AI isn't really about predicting the future anymore. It's about understanding the tools we're all using every single day. And that's the million-dollar question, isn't it? While AI can definitely feel like magic sometimes, it's not. It's all built on a solid foundation of core, understandable principles. These are the fundamental building blocks we're going to unpack together one by one. All right, let's start at the very beginning with our first 2 principles. These really form the blueprint for any AI system. Before an AI can do anything, learn, act, or create something new, it has to first understand the problem it's supposed to solve. This is its foundational knowledge. So, principle number 1 is simply problem solving. And at its core, this is what all AI is about. A self-driving car deciding when to brake, or a language model figuring out the next best word in a sentence, they're all just mapping a current situation to the action that gets them the best result. That's the name of the game. But here's the thing. To solve a problem, an AI first has to be able to represent it in a way a machine can actually understand. I mean, you can't just tell a computer, hey, go win at chess. You have to translate the board, the pieces, and all the rules into a language it can process. And this brings us right to principle number 2, representation. And there are basically 3 main ways to do this. You've got symbolic AI, which uses these hard-coded logical rules, perfect for really formal tasks like math. Then you have neural networks, which are the real engine of modern AI, built to find patterns in all kinds of messy, real-world data. And finally, there are probabilistic models, which are fantastic at making smart guesses when the information isn't perfect. Okay, so we've got the blueprint. Now we need the engine. If old school AI was all about humans writing out every single rule by hand, modern AI is all about letting the machine build its own rules by learning directly from data. And this, my friends, is our 3rd principle, learning. This learning process happens in 3 main ways. The biggest piece of the pie is supervised learning. This is kind of like studying with flashcards. You've got neatly labeled questions and all the right answers. Then you have unsupervised learning, where the AI is just handed a mountain of data and told, go find the interesting patterns in here. And finally, you've got reinforcement learning, which is classic trial and error, where the AI learns from getting rewards and punishments. But wait a second, this brings up a really important question. If an AI just memorizes all the data it's trained on, is it truly learning? The answer is a hard no. The real goal, the true test of intelligence, is something else entirely. And that is where our 4th key principle comes roaring in, generalization. See, real intelligence isn't about just reciting facts from your training data. It's about taking what you've learned and applying it effectively to brand new situations you've never seen before. This is the absolute core difference. Generalization means you understand the why, the underlying pattern. Rote imitation, on the other hand, just means you're good at recalling specific examples. One is true, flexible intelligence. The other is really just a fragile copycat. Okay, so our AI has its blueprint and a powerful learning engine. But here's the catch. The lab is a clean, predictable place. The real world? The real world is messy, unpredictable, and uncertain, which presents the next huge challenge. And this is our 5th principle, reasoning under uncertainty. The real world is not a neat and tidy data set. Information is often missing, or it might even be contradictory. A truly intelligent system has to be able to navigate all of this ambiguity and still make good, sound decisions. So how on earth does it manage this? Well, it uses probability. Think of it like a detective who's weighing all the clues. Even if some clues are missing or they don't quite add up, the AI can use these cool mathematical frameworks to calculate the most likely truth and make the most sensible decision based on the evidence it actually has. This brings us to the 6th and, maybe the most critical principle of them all. It's just not enough for an AI to be smart or powerful. We have to build it with a conscience, a set of guiding principles that steers it towards helpful and beneficial outcomes. This is the principle of alignment. And put simply, it just means we have to make sure an AI's goals actually match our human intentions and values. I mean, think about it. A super powerful tool with the wrong goal is not just unhelpful, it's dangerous. It's our job to make sure that intelligence and intention are always pointed in the same direction.
But here's the thing. Alignment isn't just one simple idea. It's a really big challenge that operates on three totally distinct levels.
So first up, you have technical alignment. Does the AI actually do what we programmed it to do? Pretty basic, right? Second is ethical alignment. Does it operate without causing unintended harm or reflecting unwanted biases from its training data? And then finally, you get to the biggest question of all, societal alignment. Is this technology truly a net positive for humanity as a whole? So making all of this happen, getting effective problem solving, true generalization, and this multi-layered alignment, it doesn't happen by accident. It requires a rigorous scientific approach. And that brings us to our final key principle: good practice. At the end of the day, AI is an engineering discipline, and that means it demands scientific rigor. That means constant, relentless testing against established standards, taking models apart, piece by piece, to see what really makes them tick, building in transparency so we can understand their decisions, and making sure our results can be reproduced by others. Trust has to be earned through rigor. It's that simple. And this, right here, is really the central takeaway. Understanding these principles, from how an AI first defines a problem, all the way to how we align it with our deepest values, is no longer just for engineers. In a world that's increasingly run on AI, this stuff has become foundational knowledge for all of us. Ultimately, these principles are so much more than just technical concepts. They are the literal foundation of the next era. They're going to shape our economy, our culture, and our society. We have the blueprint in our hands. The only real question left is, what are we going to choose to build with it?